All right, welcome to part 2 of the review of chapter 6. We're going to focus next on solving equations that have a radical in them. Again, I would encourage you to jot this down, pause the video, try it, and then come back and check to see if you got the same answer. All right, so the strategy here is basically we're going to get this radical part alone and then cancel it out by squaring both sides. So on this particular example, we minus the 1 first to get that radical part alone. So we'll have 3 on that side, and then when we square it, the whole point of this is it'll cancel out this radical on the left-hand side, giving us just 2x plus 3, and it'll give us 9 on the right. Okay, and from here, it's just kind of basic algebra. Minus 3 divided by 2. Okay, and then there's a huge piece here. On these ones, they even say you have to check for extraneous solutions. So that means we have to verify if this is a good answer or not. And we do that by just plugging it in and seeing if it works out. Okay, and if it doesn't work out, then that's called extraneous. So put the 3 back in there for x. Sorry for the bad handwriting there. But just kind of do the math. So if we start inside here, that's going to be 6 plus 3, so that's going to become 9. So we have root 9 plus 1. And we want to know if it equals 4. And so the square root of 9 is 3. 3 plus 1 is 4. Boom, so that checks out. So this is a good answer. It's not extraneous. If it was extraneous, we'd draw a line through it, and it wouldn't count as an answer. Okay, so a couple more just like that, same thing. And then the big thing is, again, when you're done, make sure you plug them in and see if it actually works out. All right, so here we can square right away because this is a root all alone. So we're just going to square it to make that side become x. But then the tricky part is when you square the other side, you've got to put it with parentheses and then write it twice because you have an x minus 6 times a second x minus 6. So we're going to have to FOIL. Okay, so this is a little bit harder because it cleans up the right-hand side when we square, but the left-hand side kind of makes a mess. So we're going to FOIL it. X times x, x times negative 6 times x, and then 6 times 6 is 36, or negative 6 times negative 6 is 36. Okay, and then clean up the left-hand side, combine those in the middle to give minus 12x in the middle. All right, and then here's an equation that has both x squared and x. So when we solve that, we get 0 on one side, and we can factor it, graph it, or use the quad formula. All right, so on this one, I would just minus the x first before we do any factoring. So now we have x squared minus 13x plus 36 equals 0. And now they've got equals 0. Now we're going to factor. And you could do quad formula again or graph it or something, but on this test, they'll all factor. So basically, it's got to multiply to positive 36 and add up to negative 13. So I would do x and x, and then it's going to be two negatives. Negative times negative will give you a positive 36, but add up to a negative 13. So we start to list pairs: 1 and 36, 2 and 18, 3 and 12, 4 and 9. And I think 4 and 9 is the pair that'll add up to 13. Okay, so that gives us answers of 4 and 9 once you set them to 0. Okay, and now we just got to do our check step, right? Make sure, and we got to check both of them because they both could be extraneous potentially. So if we test them one at a time, if we do 4, we'd have 4 minus 6. Does that equal the square root of 4? And so we get negative 2 does not equal 2. So this one's no good. So we're going to call that one extraneous, draw a line through it. Okay, and then check the 9 one. So 9 minus 6, I'm just plugging it in up here. Does 9 minus 6 equal the square root of 9? So does 3 equal 3? Yep, that works out. So this one's good. All right, so this one actually has only one real answer of 9, and 4 would be considered an extraneous solution. Okay, a little bit different style. It says which of these is extraneous, but I would kind of do the steps the same as the last couple. So pause the video, give this a shot. All right, so on this one, we're going to minus the 7 first. Okay, and then what's kind of goofy here is we have a negative in front. So before we do our square step, I'm going to divide out the negative 1 to get just the 2x on that side without the negative in front. Okay, and now we're going to square. And if you're using a calculator here, when you square negative 8, make sure you put it in parentheses. Cancels out on the left, and we get positive 64 on that side, negative times negative. And then divide by 2, and we get positive 32. Okay, and then before I go on, it says which is extraneous. So I'm guessing this one's going to be extraneous because it's our only possible solution. And so if we check, let's make sure it actually shows up as extraneous. So if we do our check here, we're going to do 7 minus 2 times 32. And we're going to see, does that equal 15? So we get 7 minus the square root of 64. So we end up with 7 minus 8, and that is not 15. That's a big X. Okay, so this one then is not an answer, which means it says which is the extraneous. That's an extraneous solution to this, this radical equation. Okay, next piece of radicals is to graph them. Okay, and just a reminder on these, there's two different shapes. When you have a square root of x, the shape kind of looks like this. And then when you have a cube root of x like we have here, it's got this part, but then it's also got a part going this way. Okay, so just make sure you know which one you're graphing. So this one, we're going to graph a kind of like a full squiggle like that. Okay, so I encourage you to pause the video, try to graph it, and then also list domain and range. Okay, so this one's our squiggle shape here, and this just moves us right to, because it's inside with x, and this part moves us up 5. Okay, and remember the right or left is weird because you think subtract would go left, but it actually goes right. So I'm going to draw a dot right to up 5 right there, and then I'm just going to draw this squiggle shape. So I'm going to draw it like that and like that. Okay, and as far as the domain and range go, domain is what is possible for x, and since it goes all the way this way to the right and all the way to the left, it's all the positives and all the negatives. All right, so x can be anything. It goes all the way this way on x, and it goes all the way this way on x, so it's all real numbers. Similarly for y, it's going up very slowly, but it does start at 5 here and go up because of this part of the graph, and then it starts at 5 and goes down because of this part of the graph. So the range is also going to be all real numbers because it goes up and down forever and ever and ever. Even though it's going up very slowly or down very slowly, it does go forever. So the domain and range there is all real numbers. Okay, one more very similar, except this one is just a square root. So pause the video, graph it, and then do domain and range. Okay, so this one we've got, that goes left 2, and then the number in the back goes down 2. So left 1, sorry, not left 2. So left 1, down 2, to get right there. And then the negative 2 in front, that's going to be both negative and 2. So the negative part is going to reflect, and the 2 part is going to stretch. So we have both a stretch and a reflection. Okay, so when we draw this one, normally we draw these ones kind of going up like this. That's what they normally look like. But we're going to draw it reflected and stretched. So it's going to be looking more like that, going down and pulled a little bit. Okay, so this thing is our graph. And then domain and range is different than the last one here. So I like to look at this point right here, this kind of like vertex point is negative 1 and negative 2. Gotta move that out of the way, sorry. Oops. So when you do the domain is what's possible for x. So if we look at our x-axis, it starts at negative 1. Okay, and you can see that in that vertex point there too, but it starts on the x-axis at negative 1. So when we compare, we start at negative 1 and then get bigger. Like as we go this way over, I don't know why I'm drawing the arrow, but we start here and go over. So x becomes 1, 2, 3, 4, 5. So the x numbers are bigger than or equal to negative 1. For the range, we're going to look at the y-axis. And we start right here at negative 2 on the y. And again, you can see that in that vertex point. And then the graph goes down from there. It goes negative 3, negative 4, negative 5. As the blue line goes this way, it goes down. So we're going to say the y numbers are less than or equal to negative 2, because we start at negative 2 and go down. Okay. One final one here, and this is just a review one. So I encourage you to pause the video and just see if you can remember how to factor. Remember, factor just means pull apart. Like when you factor 20, you just break it apart to 4 times 5. So you just got to pull this thing apart. Pause the video and give it a shot. Okay, so on any factor question, the first thing we should look for is a GCF. And they won't always have a GCF, but on this one they do. So here we can pull out an x out of all of these and put it in the front. So I'm going to put the x in front, and that will lower the exponents by 1. Okay, and then from there, this is sort of a sub-problem. Okay, and then you're going to make 2 little parentheses, and then to make the x squared, we put x in x, and then it multiplies to negative 42, so that means there's 1 plus and 1 minus, and then it's got to add up to positive 1. So I think the right pair here is 7 and 6, with the 7 as the positive 1 and the 6 as negative, because then it'll add to positive 1. Okay, and we don't got to solve it, right? It doesn't say solve, it just says factor, so that's it. We broke it apart. That's our factored expression. All right, that's it. Thank you for watching and have a good day.